So here is another example, a more realistic example than just guessing the next number, where this OHLG technique might be useful, right? So let's say I want to plot the height versus weight graph of people in your classroom, right? So think of your classroom and you want to plot the height versus weight of people in your classroom. Let's say the height is between 120 centimeters and 200 centimeters. Most people are going to be in that range, or let's say even 100 centimeters to 200 centimeters, and the weight, let's say, is from 40 or 30 kgs till 200 kgs. It can't be, hopefully it will be in that range, right? So the average human range. um, Now you might get some points like this, right? So some people who are perhaps shorter, with lower weight, some people who are taller with higher weight, and there could be other deviations also, right? So there might be some short people who are on the heavier side, some tall people who are on the leaner side. All those things can happen, but on an average you're going to see a spread like this. Now the question is, now let's say everybody in your class has given their height and weight except one friend of yours, who is not happy to reveal his or her weight, but they are happy to reveal their height, but they want their weight to be, they don't want to reveal their weight, and they are asking you to guess their weight, let's say. Now you have everybody else's data which is in this form, and now let's say you have a friend whose height is on the x-axis, which is a number that you know. Let's say this number is 150 centimeters or 155 centimeters, and now that person is asking you to guess his or her weight. How would you do this? What might be a good way to do this? Pause and think about this. I'll give you one possible way to do this, but I want you to pause and think about, what is your immediate thought about how to do this, and you can discuss this with the instructors during the live session as well. Okay, so the weight has to be in this line somewhere, right? So this person's point has to lie somewhere in this line. The question is, what is that value of weight? Now it has to somehow, there is some pattern, right? So this is the data that you have observed, and then there is some pattern that you are hypothesizing that connects weight to the height. Now what might be a reasonable pattern? Well, one pattern could be, there is, if the weight increases by some amount, the height also increases by some amount. If the weight increases by 10 kg, let's say the height increases by 10 centimeters or 15 centimeters, which means if the weight increases by 20 kgs, the height should increase also, increase in height should also double. It should increase by 30 centimeters. Well, that's a hypothesis that we are making from our knowledge of the world, right? So we believe that on an average, if the weight increases, the height increases proportionally. If a weight decreases, the height decreases proportionally. It may not be exact, right? So because your height weight relationship might depend on so many other things, right? So it might depend on where you were born, whom you are born to, what is your gene makeup, what did you eat this morning, right? That will determine your weight, right? So at least to an extent, and so on and so forth. There are so many other conditions, right? So we cannot get hold of all those conditions to really make an exact prediction, but we can hypothesize that on an average, if the height increases, from my understanding of the world, the weight should also increase. If the height decreases, on an average, the weight should also decrease. And how can I use that to make a prediction for this new person whose height I know, but whose weight I am trying to predict? That's the question. Well, I can say that there is a line. When I say proportionality, it's a linear relationship, right? So if the weight increases, if the height increases, the weight increases proportionally, right? Uh, so now here is one line, right? So okay, so I think the question that should be asked is, given your friend's height, can we guess the weight? That's the question we are asking, because x-axis is height, which is given, and then we are trying to guess the weight. Okay, here is a linear relationship, right? So let's say this is a line, a blue line, and now if we believe that this blue line is the line that correctly maps, or that we believe is the right way to map height to weight, then I know that if I give you a point on the x-axis, I will see what is the point on the y-axis where this dotted line cuts the blue line, and that would be my weight, corresponding weight. I can predict that weight. Well, why should it be the blue line? It could be the pink line, let us say, right. So, in this case my prediction is going to be here. This will be my prediction, this value of weight. Here this will be my prediction. Maybe here it is 50 kgs, maybe there it is 75 kgs. These are different predictions, right. So, they differ by a lot. Or maybe it is the green line. If it is a green line, my prediction is going to be somewhere here, maybe 55 to 60 kgs. The question is, I have hypothesized that the relation between weight and height is a linear relationship, that is, a line captures this relationship. Of course, I have agreed that because of different upbringing, different things that you ate, different places you were born in and raised, there might be small differences. The line will not exactly capture this, there are going to be differences. You might be slightly above the line, slightly below the line, but the ideal relation I believe is a line. That is a hypothesis I am making. If I believe in that hypothesis, then I have to ask which line, right. So, there are so many lines. Is it the blue line, is it the green line, or is it the pink line? Now, I will ask you to pause and think, which of these lines do you think is a better line to predict the weight given the height of your friend? Now, I am not going to answer this here, but I want you to think about this and have a discussion during the live session and give your reason as to why you think this may be the right line, right. So, is it the pink line, is it the green line, or is it the blue line, at least by looking at this data, and how would you justify your answer, right. So, that is something for you to think about. We will talk about how to do this later if if we get to that, but right now I want you to think about this, because we are just talking high level introduction at this point. Okay. So, now how is this fitting in the OHLG broader scheme of things? Well, it is exactly OHLG, because we observed the height and weight of a lot of students, which were these gray dots that you saw in the last slide, and then we hypothesized, we do not know if it is true, but then we hypothesized that there is a linear relationship between height and weight. That is, there is some line which I can use to predict the weight if given the height, some line that connects the height and weight. That is a hypothesis, right. So, that is something that I am thinking is true based on my world knowledge, that is based on my domain knowledge. That is, height and weight are linearly related, right. So, when I say linearly related, they are related using a line. Now, once I fix that, I want to know which is the line, right. So, now I want to find the best line according to some measure, and that is the question that I have asked you, right. So, you will think about what might be a good measure to say one line is better than another line, right. So, think about that roughly, right. So, why would the green line, let us say, is better than the red or the blue line? Of course, these are not just the 3 lines, right. There are infinite lines, and one line might be better than other in a certain way, and I want you to think about what is this way. But let us say we agree on some way, and then we will find the best line according to that way. And what is the use of that line? Well, once I have the line, now I can generalize, right. So, which means that I can make a general prediction for the weight given any height on the x-axis, because the line extends infinitely, because which means now no matter what point I am given on the x-axis, which is the height, I should be able to predict what the weight is, corresponding weight is, right. So, again we are observing data, we are hypothesizing some relation between input and output, we are learning from learning the best, in this case the line given the set of all lines, and now we are generalizing. This is how data and science are related, right. So, in general, this is the basics of data science. Now, the input and output could be different, the hypothesis could be different, the way you learn could be different, all those are details. We will talk about some of those in this workshop. But the bigger idea is you are observing something, you are hypothesizing something, some relationship, and then you are finding out the best way to relate input to output, and then you are using that to generalize. This trend will, whenever you are seeing a paradigm or an algorithm, later on also ask what is the OHLG question and points for your algorithm, for your paradigm or your setting that you are thinking about. Okay, great. Some points to note, right? So there is a subtle difference between the first example that I gave you and the second example that I gave you. In the first example, you know, the input and output are exactly related by the same formula. The output is always 2 times n plus 1, which means that if it is 2, the output is 5, 5 is 11, it is exactly 2 times the input plus 1 for all the data points that I observed. Whereas here it is not necessarily that, right. So, here the input output is, I give the input as height. If I think of the weight as the output, then it is not exactly some a times height plus b. That is, it's these data points don't follow a linear relationship. They are approximately linear, right. So, which means that there is some noise. I can think of it as there is some noise that corrupts the linear relationship. There is some line where I should have seen the weight for the corresponding height, but then there is some noise that gets added which corrupts this height. And that is why should we care about that? Because the noise is inevitable in real world data, right. So, if you collect the height and weight of 15 or 20 people, 20 of your friends, and then try to plot it, and that is a great exercise for you to try out with your friends, it will not fall on a line. It will never fall on a line, right. So, it's going to be extremely rare that it falls on a line, because there are these individual small variations that will push it above a line or below a line. And as people who are trying to deal with data and use data to make predictions, we need to be aware of this noise, right. So, we also always have to think about how to use, how to come up with hypothesis that also has noise taken into account, and we will talk about noise in detail much later.